Here's a summary of the automation tools and prototypes we have under development at holo-blok. Starting with smart tagging. The old way that we would do this is either tag doors one at a time, adjusting the orientation as we go, and moving them so that they align with the door leaf. Or we start by using the built-in tag all feature and taking all the doors that way. But as most Revit users know, tag all tends to make a mess. It doesn't put things where we want them. So we built a tool that can place all of our door tags exactly where we want them every time with one click. That's going to place all of the door tags aligned with the leaf right where we want it, and it's going to work with a wide variety of door types because the code knows to adjust for variations in the swing angle. If it's bifold or pocket or sliding door, it knows to align its orientation with the wall rather than the leaf. If it's a pivot door, it knows to inset the tag a little bit to clear this offset that comes with pivot. And if anything changes, such as changing an angle or changing the view scale, normally changing the view scale really messes up annotation, but we're one click away from putting everything back where it belongs. We can also do this for multiple views with a dialog that pops up where we can filter by all views or by templates. Let's just say we want to select all views of the architectural plan template. We can select all of those and place all of our tags at once. And just like that, all of these views have their tags exactly where they should be. And we can do that for as many plan views as we want. We can also renumber all of our door tags automatically. The old way of doing this would be looking at the room that the door is swinging into and assigning it that number. Or if there's multiple doors associated with the room, we would add a suffix such as 132A and 132B. And this can be a time-consuming process, especially if it's a large project that has 1,000 or more doors. So we built a tool that, again, with one click will renumber everything exactly the way we want it. And it makes renumbering 1,000 doors easier than renumbering just one door. So the code knows to look at where the door is swinging into and take that number. If there's multiple doors swinging into a room, add a suffix for however many doors there are. It also knows that if there's a door swinging between a circulation and a non-circulation room, even though this is swinging into the circulation room, it should take the number of the non-circulation room, since clearly this is primarily serving the electrical room. And now if we make any changes, adding in some more doors, it's one click to take the doors and one more to renumber them. And all of our numbering is going to be updated to be exactly what we want it to be because we have all those layers of decision making built into the code. We're also working on automating dimensioning, where we can automate all of our grids consistently across all views. If we click on this, it's going to right away place dimensions that are consistently offset from the grid bubble. And this can work in elevation and section views as well. And the nice thing about this is it's achieving a high level of consistency in our drawings because these are always going to be placed at a consistent location relative to the grid bubbles. Also accounting for scale, if this was a 1 to 50 scale, we're still going to have the same offset from the grid bubbles. Moving on to the next thing, let's say that we're in an electrical model, which in this case we are, in an Autodesk sample project, and we're looking at a mechanical link where only the mechanical units are visible, And we want to place a family instance at a consistent location relative to each of these HVAC units and maintain a link so that if anything changes in the mechanical model, our families can move right along with them while also inheriting some data from those units. So we're asking to do a few things here, but we built something that is going to do just that. Just looking at 3D in the plan view, you can see mechanical units here, 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 and here. And when we click on this Place Family at Linked Instance button, this is going to place these families, which in our case are junction boxes. In the real world, these might be pumps or motors or whatever we need them to be. But it's placing those all at a consistent location relative to these mechanical units. And it's also inheriting the mark parameter, where you can see that this is HRU 501A. If I click on this, it's got a prefix plus HRU 501A. We can have this be whatever we want. It really just depends on your use case and the kind of data that you need. This also created this parameter called the linked ID, and it gave it a value that matches the unique ID of this element. This data allows our code to determine that this family instance is connected to this, and if its location or its mark changes, then those changes can be reflected in our model as well. I'm going to flip over to our linked mechanical model. I'm going to move some things and change the location, change the elevation, rotate this one, change the marks for these two. Now if I save that and go back to our other model and reload, everything's messed up, and this is where you start hoping that your consultant partners are going to give you very thorough and complete notes so you know every instance that you need to manually update in your model. Or you use a tool that maintains that link so that we can just click this again and you'll see these junction boxes jump back over to where they're supposed to be. And also for these ones, where the mark changed, before it was 406, now it's 456, that change also occurs in our family instances. Yeah, it was this one and this one that we updated, and both of those mark updates are there. Now let's say we want to export some data from our mechanical units that are in the linked model. Let's say we want to pull the mark, the voltage, and the apparent loads. Let's click on Export Mechanical Data. For this example, it's going to create a new Excel sheet, but this could just as easily write data into an existing Excel sheet. Then we can open it, and you'll see right away that all of that data is pulled into this sheet. Now, if we want to import some data back into our associated electrical units, we can do some calculations here, give it a save and close, then go to Import, select our Excel file, and just like that, if we go over to a schedule, we can see that the values of all of these parameters are filled in for these families in a way that's associated with the mechanical data. We're also building a tool that can automate the placement of light fixtures. If I click here and wait a few seconds, we're going to get every room in the linked architectural model populated with light fixtures. Right now these all have the same spacing rules applied. Obviously that's not accurate to a real life situation, but in the future we'll be able to set different lighting spacing rules and also rules for which fixtures are placed based on whatever data drives those decisions, whether it comes from a spreadsheet or from inside of Revit or inside of a linked model. But right now this is just looking at the linked architectural model and placing different light fixtures depending on what type of ceiling is used, while also rotating elements to align with the ceiling grid. So that's a few things that we're building right now. These are mostly prototypes that can be customized to whatever your specific needs are. Please let us know if you have any questions, and we're looking forward to working with you.